right. Hello, everyone. Welcome back to our webinar series, Navigating Dataiku with Compass. My name's Ethan, and today we're going to be talking about machine learning and MLOps in Dataiku. So, a bit about Compass Analytics before we begin. We are an analytics consulting firm based in Montreal, and we really do everything related to data, end-to-end solutions, and have a very talented team that does everything from data transformation and strategy planning, data engineering, data science, AI, ML, of course, application development, and dashboarding. Here at Compass, we really believe in being teachers first and are also a proud Dataiku partner in Canada. So with that said, we're really doing this webinar series to showcase the amazing data capabilities and solutions possibilities that Dataiku has to offer. So my name's Ethan. I'm an AI consultant at Compass and based in Montreal. And I have a background in analytics, math, and comp sci, and over 5 years of experience building and deploying AI ML models across many industries like health and pharma. And I have a year of experience working on Dataiku. And as a practitioner, it really is my preferred platform for all things data science related. So very, very excited to share all of that with you today. Now, what we're going to be diving into today, we'll kick it off with a brief intro into what is Dataiku for any beginners out there. So it's just a quick overview of the platform and its features. Then we'll discuss a little bit about what machine learning is. Then we'll go into machine learning in Dataiku, kind of overview an example, case, and tutorial. And then we'll also look at some MLOps features in Dataiku as well. So what is Dataiku? Well, really, why should you use it? And where does it sit within your enterprise? So Dataiku, it's the best AI and ML engine that will get you from your silver layer data to your gold. So that, of course, comes after you've built your data engineering pipelines from bronze to silver. Dataiku makes it really easy to connect that data. From there, Dataiku excels at performing any last leg ETL and data prep before building and deploying your AI and ML models. And all of this is done in one platform with centralized governance. Finally, the output of your AI and ML projects can be seamlessly connected to your end user business applications like Tableau and Power BI for visualization and dashboarding. Now, what is Dataiku? Well, it's a centralized analytics workbench that lets you collaborate with others regardless of their technical skill. So that means basically a business analyst with no coding knowledge can collaborate with data engineers writing in SQL and Python all day, or really anyone in between. Now, what does it look like to collaborate on a project? Well, what you see here on the bottom right is called the flow. So that window with the blue squares and orange circles and green diamonds, this is the window that lets you connect data, perform your data preparation and transformation steps, build and deploy your machine learning models, and this all happens in one visual interface that anyone can understand. Finally, Dataiku is cloud agnostic, meaning it can be deployed across all your major cloud providers and integrates connections from any data source. So what is machine learning? Well, let's start with the basics. So unlike traditional systems that rely on fixed rules, machine learning allows systems to learn from data and improve automatically and systematically. It powers use cases across industries from fraud detection to customer churn prediction to forecasting demand. And ML sits under the broader umbrella of AI and includes deep learning for even more complex tasks like image or text recognition. And with Dataiku, teams can handle every step. So from data prep, model training, and deployment within one unified platform. Now, here's a high-level view of what we call the machine learning lifecycle. So it starts with problem framing, defining the business goal that we're trying to solve with ML. Then we move into data collection and preparation. So gathering our data, cleaning it, engineering some features from the data, This is followed by actually training the models, tuning and validation, and then finally testing for reliability. But it doesn't stop there. So after that, we need to deploy models into production. And just as importantly, after that, monitor and maintain them over time to detect things like drift and ensure that they stay effective and reliable and accuracy as new data comes in. And so Dataiku helps manage this entire lifecycle. And machine learning doesn't really stop once the model is deployed. So like I mentioned, it needs to be maintained and continuously improved. And that's where MLOps comes in. So MLOps stands for machine learning operations, and it's the discipline of managing the full machine learning lifecycle with reliability, scalability, and automation, just like DevOps, but for models. So this infinity loop that you see here shows the continuous nature of the MLOps cycle, starting from data, model building, moving through testing, packaging, deployment, and then serving predictions and monitoring performance before looping back to iterate. And Dataiku supports this entire flow, letting you plan, train, deploy, and monitor models in a way that's integrated, traceable, and production ready. Now let's actually get into the machine learning platform in Dataiku. So first off, Dataiku does support the full spectrum of machine learning workflows from auto machine learning to fully custom code. So with AutoML and Visual ML, you can rapidly prototype and deploy models for prediction, clustering, time series, causal inference, and computer vision. These tools come with built-in explainability features, including fairness analysis, stress testing, what-if scenarios, ensuring transparency and trust in your models. So for advanced users, then, Dataiku allows the integration of custom models developed in Python, R, or imported via MLflow. These models benefit from Dataiku's MLOps capabilities, such as visual scoring, evaluation, drift analysis, and deployment within the platform. Dataiku's MLOps framework encompasses the entire model lifecycle, from training and evaluation to deployment and monitoring. Features like unified monitoring provide a centralized view of model health and drift status, ensuring that teams stay informed on all deployments, regardless of the infrastructure. So this dual approach really empowers both the analysts and data scientists to collaborate effectively, leveraging a shared environment that supports both no-code and code-based machine learning workflows. Now let's break down some of the key concepts you'll see in any machine learning flow in Dataiku. First, we have the data sets shown as blue squares that represent your data inputs and outputs, and they can live anywhere. So S3, Snowflake, Postgres, SQL, or even local storage. And the icon you see in the middle of that blue square is indicating where that data lives. Next, there are recipes shown as circles. The visual recipes in particular are these orange, yellow circles, and they represent steps that transform the data, like cleaning, filtering, or writing code in Python or SQL. Finally, models are shown as diamonds, and these are your predictive tasks, whether it's classification, clustering, regression, or time series. Together, these icons form a visual end-to-end machine learning pipeline that's easy to understand, modify, and scale. So we'll start this example, and we'll assume you have some data that's been prepped and joined. And the next step to get your data ready for modeling is going to be splitting it out. And in Dataiku, we do this with the split recipe. So it's as easy as selecting your input data set and defining two outputs, one for training and one for testing. And this setup helps us train the model on one portion of the data while preserving another portion to evaluate its performance fairly. And we can launch the recipe right from the flow and configure everything through a visual interface, no code needed. Inside the split recipe, we have this really easy, simple graphical user interface, and this is how we'll choose how the data is divided. And here we're using the method full random dispatch. And we've set 80% of the data to go into the training set and the remaining 20% into the test set. So you can also configure additional ratios here or set a random seed to ensure your results are reproducible in the flow. Once everything looks good, you can click Run, and you'll get two clean, managed datasets ready to feed into model training. Now, with our training data ready, we can now build a model using Dataiku's visual ML interface. So we start by selecting the train dataset in our flow and opening the lab. Here you'll see a range of modeling options. So we have AutoML for predictions or clustering, time series forecasting, image and object detection, and even causal inference. We're going to choose AutoML prediction, which kicks off a guided workflow to help us train a supervised model with minimal configuration. So next we'll select our target column, and in this example case that we're going to work through, we're trying to predict whether a transaction record from a database of transactions is fraudulent. And Dataiku offers a few AutoML pathways depending on your goals. So there's quick prototypes for rapid experimentation, interpretable models for business analysts, and high-performance models for deeper accuracy. If you want full control, you can even move into expert mode and choose algorithms, fine-tune hyperparameters, and even build custom estimators. For now, we'll use the quick prototypes path. You just name your analysis and hit create to start configuring your model. Now, once you've created the prediction task, training the model is just a few clicks away. You'll land in the Design tab. This is where Dataiku has pre-configured a baseline setup using your selected features and default algorithms like logistic regression and a random forest. Simply hit train, and Dataiku will run multiple estimators. So here it's evaluating 37 estimators in total across 2 models. You can optionally name your training session or add a description, but it's not required. Just click train again, and the platform takes care of the rest. Once training finishes, you're taken straight to the Results tab, where you can compare model performance side by side across sessions. Here you can see that the random forest model outperformed the logistic regression, achieving a higher ROC area under curve score versus, so the random forest beat out the logistic regression model. And then you can also get diagnostics like the training time for each model, the number of rows used in training, and the top contributing features for each model right in the Results tab. And this makes it really easy to interpret the model behavior, identify strengths, and choose the best performer for deployment. Now, understanding how your model makes decisions is just as important as how well it performs. And in Dataiku, we can check the feature importance using Shapley values, which show how much each feature contributes to the model's predictions. So in this example, for feature importance, we see features like country, company profile length, and has company logo are among the top 3 drivers of prediction. And this feature importance is just one tab of the mini explainability tabs that you can go into to get a better grasp of how your model is performing and why it's giving the predictions and outcomes that it is. And these insights overall will help validate the business logic, uncover bias, and build trust with your stakeholders. Next, if we want to evaluate how well the model actually performed, we can go into the performance tabs. The first one is one of my favorites. It's the confusion matrix. This gives us a clear breakdown of true positives, false positives, and other key outcomes. So below it, we get a full set of metrics as well, like accuracy, precision, recall, and F1 score. And this lets us understand not just how often the model is right, but how well it handles the trade-off between false alarms and missed detections. So you can also adjust the prediction threshold to fine-tune your model here based on the business objective. Now, lastly, Dataiku gives you full transparency into how the model was built. So under the model information section, you can view every feature used, how it was encoded, and which variables were excluded from training. This level of detail is great for auditability, reproducibility, and just understanding what processing steps were automatically applied behind the scenes. It's a complete record of how your model was constructed from raw input to deployment-ready artifact. Now, we can go back to the design tab, and this is where you'll iterate on and refine your model setup in the visual ML interface. So here you can choose, for example, in the target setting, the prediction type, either binary, multi-class, or regression, and then define your target variable. You also get visibility into if there's a class imbalance, which is key for tuning performance. As you scroll through the left-hand menu, you'll find full control over how features are handled and generated or reduced, as well as how data is split and what metrics are being used for optimization. Under modeling, you can select from algorithms like logistic regression, random forest, XGBoost, support vector machines, or even deep learning models powered by TensorFlow. And you can, of course, fine-tune hyperparameters with strategies like grid search or random search, or use built-in defaults to keep things really simple. And if needed, Dataiku also supports bringing in your own models. So you can actually define custom model algorithms in Python, provided they implement standard methods like fit and predict. These custom models can be integrated into the visual ML design, benefiting from Dataiku's pre-processing, evaluation, and deployment features. Additionally, you can extend the platform by creating a plugin that adds new algorithms to the visual ML tool. So this will enable you to really tailor the modeling experience to your specific needs. Now, overall, Dataiku's visual ML is a very comprehensive environment for both standard and custom machine learning workflows. Now, once you've selected your best performing model, it's time to deploy into your Dataiku flow. From the model's results page, you can simply click Deploy in the top right corner, and you'll be prompted to confirm a few basic settings like which dataset the model was trained on and the output name for the prediction recipe. Behind the scenes, this creates a reusable scoring recipe, allowing you to apply the model to new or unseen data at any time. Deployment is fast and code-free, and it keeps your models versioned and traceable, ready for batch scoring, automation, or MLOps workflows. Now, once your model is deployed, you can now use it to generate predictions on new data. So this process is called scoring in Dataiku. And in the flow, you can select your model and choose the score recipe, then specify the input data set, in this case, the test set that we split out earlier in our flow, and then configure where the prediction should be saved in a new output data set. Dataiku gives you control over the output format and storage location, of course, like any recipe, making it really easy to integrate scoring into downstream workflows. Then click on the Create Recipe and you'll have a new dataset enriched with the prediction scores, ready for further analysis or decision making. So once scoring is complete, you can actually open up that output dataset, and here we'll inspect the results. So alongside your original features that you had in your input dataset before testing and scoring, you'll see new columns here, proba1 and proba0, which show the model's predicted probabilities for each class. Here it was 0 or 1, false or true, and then a final prediction column that indicates the classification label. These results give you a very detailed view of not only what the model predicted, but how confident it was in each case. You can now use this score dataset for reporting, decision-making, or to trigger any downstream workflows in your project. Now you have trained a machine learning model. Let's talk about how you can actually operationalize that now in Dataiku. So Dataiku makes it very easy to deploy models for real-time predictions by exposing them as APIs on the API node. Or for scheduled batch processing, you can deploy your model and project on the automation node. You can also track model performance over time using what's called an evaluation store in Dataiku, which lets you monitor key metrics like accuracy, F1 score, and calibration across different versions and data samples. And with built-in drift detection and alerts, you can proactively respond to shifts in your model behavior, ensuring that your ML systems stay reliable and production ready over time. Now we'll walk through a simple demonstration of how you could deploy a model on the API node and explore some MLOps features that bring everything together. So to serve predictions in real time, we start by creating a scoring API from our trained model. So from the flow, you can select your deployed model, that green diamond that we created earlier, and choose Create API. You'll give your service a unique name, and this will be the container for your endpoint. Then you'll also define an endpoint ID for the actual scoring route. When you click Append, this will register the new endpoint with the model, and now it's ready to be published. So now that the endpoint is created, we need to publish it to the API deployer. We'll click Publish on Deployer to package the endpoint as a version service in Dataiku. You can give this version a label like V1, iterate from there, V2, V3, and so on, and even add release notes to track what's changed across your versions. This step is just going to ensure that the model is portable, trackable, and ready to use in your production environment. So from the deployer interface, we select the new version and hit deploy. You'll choose the infrastructure where the model will run on, such as the specific API node cluster, and assign a deployment ID. Once you press deploy, the scoring service becomes live and ready to receive prediction requests from external applications. After deployment, you'll receive that live API URL that can be used to access your model over HTTPS. The service is now running and versioned in Dataiku with full monitoring and governance baked in. You can review things like the model metadata, you can check your deployment status, and update versions, all from a centralized deployer interface. And before going live even, you can test the endpoint right in Dataiku. So if we head over to the Run and Test tab, this is where you can input sample records and see real-time predictions returned by the API. This is going to be very useful for validation, debugging, or sharing results with stakeholders before full integration into your business applications. With just a few clicks, we've now gone from training a model to deploying it as a real-time prediction API. And we've created the endpoint, versioned it, deployed it to infrastructure, and tested its outputs, all within the same easy-to-use unified platform. This is really the power of MLOps in Dataiku. It's seamless, it's governed, and it's production ready from start to finish. With that, I'm going to conclude the presentation and open up the Q&A board for any questions that you have. So I see one question from Julian on splits. Yes, you can do more complicated splits. Stratified is something that Dataiku supports, and for time series split, you can, of course, choose something like a date to split before, a date to split after when you're working with time sampling. Vasily is asking, can you add custom metrics for the model training? Yes, you can. So Dataiku, of course, for each model has the basic metrics like you use, like it might use accuracy, your F1 score. You can, of course, then build your own custom metrics. So you can bring your own models, you can define your own metrics, and then how your models are ranked, you actually get to choose that metric, which could be the pre-built ones or the custom that you define in a Python function. All right, I hope that answers all your questions. Um, Now, I just want to say thank you all for coming. And our next upcoming webinar is going to be on May 29th at 11 a.m. It's going to be on visual ML in action. We're going to model, deploy, and monitor with Dataiku. So we'll be again discussing the machine learning features and MLOps features in Dataiku, but just going a bit further and really tackling a real business problem on the platform. So I hope to see you all there. Thank you and have a great rest of your day.